some slight internet issues, and resetting my router and my modem didn't fix it. So I'm going to have to deal with that after this class and reset all my IP addresses, and hopefully that will work. But until then, I am aware that my internet connection isn't stable. So what the problem is that my upload speeds aren't very high. I'm going to be trying to live streaming this to YouTube, but in case, so my last class, it didn't work. If it doesn't work this time, I will be posting this video to YouTube the old school way, which takes a lot longer to do. So yeah, so what I'm going to do is I'm just not going to do the live stream, and that's probably going to fix things. So I can't do the YouTube live stream, which means that this video is going to take a long time to load up to YouTube. So if you guys are looking for this video on YouTube, it probably won't be up until later tonight, and I apologize for that. Okay, so again, the live YouTube stream is not working, but this video will be posted on YouTube because I'm recording it locally. And hopefully changing that, the quality got a little bit better. But I am aware that my internet isn't working well, and I'm trying to fix it, but I can't fix it while we're in class. So let's go over this warm-up, and let's talk about what we're going to do. So inductive reasoning, right, is about seeing a, so you see a pattern. So you go from a pattern, and then you generalize. I gotta spell generalize right. Okay, so when you generalize, right, you're going from, so you're taking a pattern and then you generalize it to everything else. So for example, we talked about number sequences. We talked about, like, hey, seeing your mom go and buying milk at the store, right? Just because you see it doesn't mean that it's always going to happen or that it happens with everyone. Deductive reasoning is when we take a law or a rule and we apply it to a specific case. Okay, so that's the difference between those two. So remember, we're really good at inductive reasoning naturally, right? So we're really good. Humans are, that's what humans are good at. They're good at finding patterns and then generalizing it. But we're really going to focus on deductive reasoning with laws and rules and then applying that to specific cases to see what happens. Okay. The law of detachment says if P is true, then Q is true. Okay, what's important here, it doesn't say if Q is true then P is true. So this is it. There's nothing more to this. So if Q is true, that doesn't mean P is true, right? So what I mean by that is if I say if I'm happy, then I eat ice cream. Okay, so if I'm happy, that means that I'm eating ice cream. But what it doesn't say, right, because this is our P, this is our Q, is that if Q is true, if I eat ice cream, that doesn't mean I'm happy. I mean, it could mean that I'm eating ice cream and I'm really sad, and so I'm trying to get the ice cream to cheer me up, right? So it's really important for law of detachment. It says if P is true, then Q is true. It doesn't say if Q is true, P is true. So it's only, so Q is only true if P is true. Okay, so and you guys probably saw this on your homework when doing this, right? When you're using the law of detachment, you're just making, if P happens, then you know that you're going to have ice cream, okay? So again, we're trying to be as robots. I know this is a silly example, but that's what's going on with law of detachment. If P is true, then Q is true, but it doesn't work backwards. So if Q is true, that doesn't mean P is true, okay? So we can't make assumptions based off the conclusion. Law of syllogism is the two statement ones. So if we have if P, then Q, and if Q, then P, right? So we have two statements. Then I can write a new statement that says, see how this is like filler? So we kind of think of law of syllogism as the chain rule. So we're going to, rather than go through this long story, we're just going to jump from the beginning to the end. So then we can say if P, oops, I didn't mean to say P twice. I meant to say R. If P, then R. Okay, so the idea is, and you guys might have this in your life, right? When someone's telling a long story, you're just like, you could have just said the beginning and the end. It's a way of taking something that is really long and making it shorter, right? So the law of syllogism says if P then Q and if Q then R, then you can just go from P to R. Okay, so that is there. And that's what we talked about last class, right? We talked about inductive versus deductive reasoning, and then the law of detachment, law of syllogisms, they're laws, so they're types of deductive reasoning. Okay, so what we're going to do today is we're going to do more deductive reasoning, but with stuff you're already familiar with, and that is algebra, right? You guys already have learned a whole bunch of algebra rules in order to solve things. So what we're going to do to get you guys into proofs is we're going to start with something you already know. We're just going to change the format a little bit, okay? Now, anytime that we're going to do proofs, we need a list of rules, right? Because we're using deductive reasoning. So what we're going to talk about first, because we're doing algebra proofs, is we need a list of rules. So we need a list of algebra rules. My hands are so cold and they hurt so badly it's hard to write. So if my handwriting is exceptionally bad, I am really sorry. It's just my hands are freezing. All right. Oh gosh, gotta warm up my hands. So what do we have? So the first ones that we have are called the properties of equality. Now, some of you might be like, ooh, yeah, we're going to talk about social justice. Wrong type of equality. This is math equality. And this is often abbreviated as POE. Okay, properties of equality. So with properties of equality, these are all ones that you already know. Adding, subtracting, or subtraction, multiplication, and division. Okay, so again, you guys already know how to do these algebra things, right? These are called properties of equality. Now, for this year, we can drop the POE. But basically what the POE, what this means, it means that you do this to both sides of, an equation. And that's why it's called properties of equality. It's just that we have an equal sign and we have to do it to both sides. And you guys learned this in algebra, right? If you add something to the left side, you have to add the same thing to the right side. If you subtract, multiply, or divide something from the left, you have to do the same thing to the right. So you guys have already learned these rules, right? So you guys have already been doing deductive reasoning, right? So these are things you guys know. We don't really need to go into them. It's just you need to have them written down and be like, okay, these are rules I can use, right? So adding, subtraction, multiplication, and division. Okay? And they're called properties of equality because you do them to both sides of an equal sign. Okay? And then let's take a look at another set. We have another set, so other properties. Man, I don't know how I'm going to make it through today. My hand physically hurts because it is so cold in my basement right now. This is not good. Turn up the heat. Okay, so other properties. So we're going to talk about other things that we've done in this class and you've done in algebra. So some things you've done in algebra is like substitution. So substitution property. So the big place you guys did substitution, and you might be thinking about this, is when we had systems of equations. So in systems of equations, right? So we had maybe like x equals y plus 2, and then you had x plus y equals 20. Right? Remember, substitution says, well, if x equals this, then anywhere I see an x, I can replace it with that. So I would get y plus 2 plus y equals 20. Okay? That is substitution. And this is something, I know maybe systems weren't your favorite thing in algebra, but this is what substitution is, right? So it's when you take something and you replace it. Substitution is also used in sports, right? When you make a substitution, you're replacing one thing with another, okay? They're equivalent. Okay? So that's what substitution property is. And then we have another one called distributive property. I can hardly write. This is terrible. Distributive property. Okay. So distributive property, that's something that you guys have also seen in algebra. Now, distributive property isn't a property of equality because you just do it on one side of the equation. So for example, if I had 5 times x plus y equals 12, right? So we have distribution when we have something that's grouped. So I always like to think of it as a shopping cart, and then you're multiplying everything in that shopping cart by the number on the outside, okay? So this would be 5x plus 5y equals 12. So the 12 isn't affected there, okay? So again, I know I'm kind of going through this kind of quickly, but this is all stuff that you guys have done in algebra, okay? So we have adding, subtracting, multiplication, division, substitution, and distributive property. Okay, so what we're going to do now is we're going to do algebra proofs. And what you're going to find is that the only difference between an algebra proof and a solving an algebra problem is that we're just going to write down our reasons. We're going to justify every step. So let's do that together. So let's do our first algebra proof. Okay. And you'll see what I'm doing here in just a second. So what we're going to do, so this is we're going to call this example 1. So I'm going to have, we're going to solve, let's do this, 3x plus 2 equals 23 minus 4x, and we're going to justify all of our steps. Okay, so we're going to solve this and we're going to justify our steps. So again, a lot of you are going to be like, correct, I got this, I can solve this, hopefully, right? But what's new is this justify our steps piece, and this is what proofs are all about. Because in math, remember, the right answer, I know a lot of you guys think the right answer is what it's all about, but that's not true at all. What's really important is how you get your answer, because there's so many different ways of getting your answer. And if you do everything right getting to your answer, that means your answer is correct. And students always ask me like, well, is this correct? I don't know if I got it right or wrong. And in math, remember, you don't need someone to tell you if you're right or wrong. If you did every step correctly, then you have to be right. Okay? And that's what's cool about math. If we're living in deductive reasoning, there is a right answer, there is a wrong answer. So as long as you use the deductive process, whatever you come with at the end has to be correct. See how that's really different than inductive, right? Because in inductive, it's just a pattern. But with here, we're definitely going to have a right answer. So what we're going to do to solve this is we're going to make a t-chart. And on the left, we're going to have our we're going to have our statements, and we're going to have our reasons. Okay, so the reasons is what's new. So it's an added formality. Okay, so the idea is if you were to able to think of math in this way, you would never need someone to tell you if you're right or wrong, because you are checking, am I doing the right process? Okay, so the first thing that we always do, and you should label your steps so that the work is easy to read, is you start with your given. So it's given. This problem was just given to us, right? It was just like Kreft gave it to us. That's what it is. So why do we start there? It was given. Okay? You're always going to be starting with at least one given. Okay? So this is our given. Our given is the equation. Okay? So now, what do you guys want to do? So in chat, tell me, what do you guys want to do first? What step? I'm going to solve this algebra problem. What do you guys want to do first? Because again, there's so many different ways to solve this. There's actually an infinite ways to solve this to get the right answer. So what do you guys want to do to solve this? What do you guys want to? Okay, so one person said they want to add 4x to both sides. So again, we're going to do one step at a time. So if I add 4x to both sides, so that the goal here, it would seem, would be getting all my x's to one side. So 3x plus 4x, so this is going to be step 2 now. 3 plus 4, so that's, I got to use my fingers here because my calculator's away. So I have 3 plus 4 is 5, 6, 7. So I have 7x plus 2 equals 23. Now I have to write, how did I get here? Okay, so what did I do? I did addition. Now, I'm going to write POE because it's habit, but you don't need to write POE. But anytime you do something to both sides, right, it's important to note that this is addition, property of equality. So I added the same thing to both sides to keep it equal. Okay. How are we doing with that, guys? Do you guys see how we're solving it, but we're justifying our steps? That's all a proof is, right? A proof is saying, what deductive rule did I use, right? And this is a deductive rule, so this has to be correct, right? That has to be correct. So then, let's keep going here. So my next step, I heard someone say subtract. So what if I subtract 2 from both sides? So then my third step is going to be 7x equals 21. And what did I do here? I did subtraction. And then again, you don't have to write POE. It's habit for me because, again, I'm keeping the equal sign real, right? I'm doing the same thing to both sides. I subtracted 2. I subtracted 2. Are you guys doing okay so far? This is slightly new, right? But this is a proof. You might heard from your peers or friends, all proof are terrible. But, like, this is it. It's just a game, right? You have rules. All games have rules. And we're using those rules to get to the end of the game. Okay? So the next step here, it looks like I have 7 times x. So I'm going to undo that, right? So my fourth step is going to be x equals 7 goes into 21 3 times. And then what did I do here? I did division, and I did it to both sides. All right, and then take a look. We're done. Now, I'm not going to require this, especially in COVID times, but if you were to be writing a formal proof, you would put a box like that, and the box is basically a period, like we're done with this proof. That proof is done. Okay? So what we just did, notice how this is solving, but by doing this, not only did I solve for x, but I backed it up. Not like back it up like I'm throwing my booty on the dance floor, but I backed it up in, like, if I was having an argument with someone, right, then there I go. I'm set. This is, right, I'm solid. I did everything according to rules. Okay? And yeah, I got some pretty sick dance moves. So I'm just saying, if you guys, when school gets back in session, you guys want to do a dance off, I'm just saying, like, you're going to get burned. So maybe get the fire department to come and be there. Okay? Because I bring the heat. All right, that's it. Okay? You guys can do this. You guys can do this. You guys can do this. We're going to do... so what do you guys think? Do you want to try one on your own? I think you could try one on your own. I'm going to ask that you guys try one on your own and see what you get. Okay? Oh, my hand hurts so badly. I'm going to go, after this, I'm going to go run my hand in hot water. Okay. So the next one we're going to try is this one. So we're going to solve -5 times the quantity of 7w plus 8 and then equals 30. And we're going to justify each step. So I'll get you guys set up, but then I'm going to have you guys do this. So I always have students say like, Mr. Kraft, do I always have to do a T-chart? Do I always have to write statements and reasons? And then my response is, well, I don't know. In English, do you always have to write in complete sentences and paragraphs? Okay, so you do. So again, writing down the first step isn't really getting work done. So I'm going to write that down for you, right? So -5 times the quantity of 7w plus 8 equals 30. And my reason for that is it's given, right? That was given to me. So I'm going to give you guys, let's do 2 minutes. And I want you guys, so now doing proofs is new. So I found that some students, they just like to go, and remember, you can't do multiple steps at once. You have to do one step at a time. This is why people kind of like hate proofs. It's like, I want to skip steps. You can't. So go one step at a time. So some people like to go one step at a time and then fill the reasons in afterwards because they're more comfortable with doing the algebra. But that's up to you. I like to go do them at the same time. Okay? So see what you can get, and we'll compare notes after 2 minutes. Okay? And see where we are. All right. I know that in a perfect world, guys, we'd have more time to do everything, but I only see you guys twice a week, and I haven't seen you guys in 5 days. So we're going to go over this. And what I want you guys to do, I'm glad that you're doing this and you're doing it on your own, is that you're going to take a look, okay, what did you do? What did I do? And then if they're not the same, let's get them the same. Okay? So the first thing we're going to do here is we're going to distribute. Okay? So I'm going to get my step 2. So a negative. So, and again, if you guys need, calculators or Desmos, right? Desmos is a free online calculator, or you can download the app. I'm going to multiply here, so I get negative 35W, and then negative 5 times 8, I get negative 40 equals 30. And then for my reason, right, I'm going to write distributive property. Distributive property. And you can abbreviate property as prop. Just as long as you know you're not talking about something that you use on a stage or maybe a proper propeller plane. Okay? All right, so prop. So distributive property. Okay, so that's what we did there. And again, as I'm going through this, if you have questions, please ask. Okay? So now I want to get this W by itself. So I'm going to undo this minus 40 by adding 40. Okay, so I'm going to have negative 35W equals 30 plus 40 is 70. So I'm going to have, that was addition. And then I did it to both sides. That's why I like the POE. Don't ask me why the P wasn't capitalized. It just was it was. Okay, POE. There you go. And then I have negative 35 times W. Well, I want the W by itself, so I'm going to do the opposite of multiply. I'm going to divide. Oh my gosh, something beautiful. Negative dos. Okay, and then what did I do here? I did division POE. And then, boom, I'm done with my proof. So this was 4 steps. Okay, so I'm going to hit pause here for a second. Do you guys have any questions or comments? Hopefully you guys are looking at this and be like, yeah, I can totally do this, right? So again, a proof, right, is about doing the work, but also backing it up. Now, again, you might be like, this seems like a lot of work just to do an algebra problem. And you're right. We wouldn't normally do this with an algebra problem, right? We're going to normally do this with other things. I'm just using algebra as a way to teach you the 2-column setup with statements and reasons. Okay, so again, this isn't what we're going to be spending most of the year on. I'm just giving you the format, okay? And it's easiest to do the format with something you already know, right? So you already know algebra. All right, so I haven't heard any back from anybody. Are we doing okay? Does anybody have any questions? Am I going too fast? Is that why people aren't responding? I appreciate the feedback. Again, if anybody has a question, I'll answer anything. It's like YouTube or Twitch, right? Like you guys are chat's blowing up, and I'm all like, oh, da-da-da-da-da, you know, like, come on. I can't become famous unless you guys make me famous. I guess that's what I'm trying to say. Poggers, right? Mad poggers. Okay? All I'm going to say is that I am totally GOAT. So, just saying. All right. So, this is what majority of your homework is going to look like. Okay? It's going to be, and I think it's all of your homework. You're going to be doing algebra problems. So, there's going to be 2 parts to your homework. One, you're going to be doing algebra problems, and you're going to be giving reasons. Sounds good, right? And then the other part is it's going to show you something, and it's going to say what rule was used. Okay? So there's 2 parts to your homework. Now, with that said, it would be awful if I just ended here without doing any geometry. So I'm going to drop some new geometry properties. Okay? So that's the algebra. So let's talk about new geometry properties. Now, when I say new, it's just going to be new names. POE stands for, it's also a video game. POE stands for something of equity. Oh my gosh. Properties of equality. Properties of equality. And if you want, it's in your book too, but it's properties of equality. Sorry, all I could think about was the video game, and the video game is called Path of Exile. Sorry. POE, properties of equality. That was a great question. Thank you for asking. Yep. Okay. So new geometry properties. So they're only new in name. These you know these, you just didn't have the name to go with them. So the first one is reflexive property. Now, I'm going to tell you a little story about this one. So this one, you're like, reflexive? What? I've never heard of that, but you told me I know it. So you know this. So what I like to think is I like to think of the word flex, okay? And then think of like those people who like work out like super hard in gyms and like they're like pumping some serious weight, right? And then what's better than after pumping some serious weight, but like, you know, have you guys been to gyms and they have those big wall mirrors and just like checking out your newly defined muscle in the mirror, and you're like flexing, you're like, oh yeah, I just lifted 5 pounds. Take that 5 pounds. All right, so the idea is if you right, hey, it's okay to be a stick. You can have muscle and be lean. Reflexive, remember, it just takes, right, it's just like growing muscle in your brain with school. It's super important to grow muscle on your body as well. So reflexive. So when I think of reflexive, I think of flexing in a mirror. So when you flex in a mirror, what do you see? You see yourself. You see your reflection. So reflexive just means something is equal to itself. Something equal to itself. Oops, self. I promise I'm not just thinking about how good my body looks in a mirror. Okay, that was creepy. Something equal to itself. So for example, 7 equals 7 is the reflexive property. Angle A is congruent to angle A is the reflexive property. W equals W is the reflexive property. So when something equals itself, we call that reflexive. And you can think when you flex in a mirror, you're just seeing yourself, right? Okay. And if you spend a lot of time on yourself, then it feels really good because you're like, I spent a lot of time. Like, good. Okay. Straight flexing. All right. So that's reflexive property. Symmetric. So some of you might see the word symmetric and you might think symmetry. And if you do, good, because symmetric actually does come from symmetry. So symmetric just means you can switch sides of an equal sign. Now, this sounds more confusing than it is, but symmetric says you can switch sides of an equal sign. You have done this. Your teacher and you did this, and you just were never told you couldn't do it, right? So what I mean by this, and here's an example. I should do this in black. Here's an example. If 7 equals x, then x equals 7. Right? Like in algebra, didn't you just do this? I think this is a really petty property. Like, who would like take the time to write this down? But it's there and it's true, right? 7 equals x is the same as x equals 7. And you can do this with symbols too. So for example, if angle A equals angle B, then angle B is the same as angle A. So again, the symmetric property is just switching sides of that. You know, like, why isn't it just called switchy? The switchy property. The switchy equal sign property. Like, so these names, you have to remember, math comes from a really, really, like, historically long time ago. So, so a lot of the times these words were created in Greek or Arabic, and then they were translated to English. Okay. So anyways, right. So like some people are saying like reflective makes more sense here. Hey guys, I'm not disagreeing with you. I'm not disagreeing with you, but it is what it is. Symmetry. So symmetric comes from symmetry. And if you think about it, what's symmetry? Symmetry is the left side and the right side are symmetric. So the idea is it doesn't matter if it's on the left or the right. So there is some logic there. Okay. The last one is the most important one. Okay. And that is the transitive property. Now, people always get confused about transitive because transitive and the law of syllogism are almost identical. Okay, so one way people like to think of it is the law of syllogism is basically transitive property. And I just want to double check really quickly how they say it in the book. Yeah, it's basically law of syllogism used in application. Okay, so rather than saying law of syllogism, we say transitive property. So it's basically chain things together. So oh my gosh, get it together, Craft. All right, so what I mean, the example is going to make more sense. The transitive property is when we chain. So we're going to have, let's say I have x equals y, y equals c. Okay. So then what's our new statement? X equals c. Okay. It can get longer than this. So it might be like this. It might be more complex. Okay. Let's say angle A equals angle B. Let's say angle B equals angle C. Angle C equals angle E. So then I can say angle A is the same as angle E by transitive. Okay, so transitive property is basically law of syllogism. Okay, but we're not going to write law of syllogism because the difference here is that the transitive thing is a property, and we're going to use properties in proofs, whereas law is like it's more of a general thing. This is specific to math, if that makes sense. So we're going to be using transitive property. So transitive property is when we chain things together. So instead of saying a whole bunch of things, so if we know x equals y and y equals c, then we know x equals c. Okay, so that's the transitive property. Now, I know that we get out at 11. So what I want to do today, and I just want to make this super clear, what you're going to have on your homework is you're going to have, it's going to say, solve this algebra equation and justify your steps. So you're going to solve and you're going to justify your steps. Okay, it might not be in a column on big ideas, but we're going to be moving to columns in the future. Okay, and then it's going to give you statements and it's going to say what property is being used. So what I mean by that, so this is just a preview of your homework. If I have zy, segment zy equals segment zy, I would say what property is this? And you would say this equals itself. So this is reflexive property. Okay, so you're just going to be looking at a statement and then you're going to have to say what property is being shown. Okay? That's all it's going to be. So make sure you have these down in your notes. It's going to give you an example. So like, do you see here how like we wrote it, then we had an example? So your homework is backwards. It's going to give you an example, and then you have to say, what property is it? You guys can do it. I know you can. And if you have questions, you can always email me. Now, with that said, I have 10 minutes. And what I want to do, there's not going to be any geometry proofs on your homework. But the problem is that geometry proofs get harder because it's new, right? You guys have done algebra, you haven't done geometry. So I want to do a geometry proof with you just to get you guys comfortable so that next class it won't be awkward. Okay? So with that said, I encourage you guys to follow along and let's take a look. So I'm going to have a diagram. Now, this diagram is a mirror. And what I'm going to do is I'm going to have a light source, like a laser, and the laser is going to come, it's going to hit the mirror, and then it's going to reflect off the mirror. Because part of what I'm doing today is I'm kind of proving a physics property. It's called Snell's law. And what Snell's law says, if you take a light source and it hits a perfect mirror, the angle of incidence, or the incoming angle, is the same as the angle of refraction, or the outgoing angle. Okay, but we're going to do a little proof with this. So I'm going to go ahead and label this. So I'm going to have A, B, C, D, and E. And again, all that stuff about physics, I was just doing that to make this exciting. It is not. It's just called Snell's law. The parabola effect is something different. Though I wish I had more time, guys. We would talk about physics. Physics is actually my main passion, not math. But we're just going to do this. We're going to do with what we have time. So it's going to be given that this is angle 1, this is angle 2, and this is angle 3. And notice with the arcs, it is given that those two angles are congruent. Okay? So what we're going to do is we're going to prove that angle, let's do here, the measure of angle DBA is the same to the measure of angle EBC. Okay, so we're going to take a look at these two angles. Okay, so we're going to prove that angle DBA. So if I go like this and I cover this up, you guys see angle DBA? It's that big one. It's angle 2 and 3. And I'm going to take a look at angle EBC. That's angle 1 and 2. So this big obtuse angle, I want to show that it's the same as this big obtuse angle. And we're going to do that using a combination of algebra and the properties that we learned. Okay, so let's go ahead and do this. I'm going to write a 2-column proof. I'm going to write statements, and I'm going to write reasons. Now again, guys, this is brand new, so it's going to be a little bit confusing. I want you to ask questions if you have them and follow along. Okay, so again, the first thing I always do is I start with my given. Now, in this case, my given is in my picture. The measure of angle 1 is the same as the measure of angle 3, and that was, and that was given. Common mistake I wrote 2. Okay, so this statement is given because in the picture, it says these two angles are congruent, right? With the little arc there in both those angles, that means both those angles are the same. That is the mark for congruent for an angle. Okay, now you're like, okay, I'm a little overwhelmed. With algebra, I know what to do. So in geometry, the trick is look at the answer. This is the answer, guys. Isn't that cool? Like in proofs, you know the answer. Okay, so we're gonna. In real life, this is called reverse engineering. We're gonna start with the answer about angle DBA, and I need a statement about angle EBC. So what I'm gonna do is I'm gonna do that first. I'm gonna say angle DBA is equal to what? So let's take a look at angle DBA. So here I have angle DBA. Well, now this is something that we worked on in the last unit, right? So isn't this angle addition? Angle DBA is really made up of two smaller angles, right? Angle 2 and angle 3. So I can say angle DBA is actually angle 2 plus angle 3. Okay, and my reason here is angle addition. You guys remember doing that? So again, if I take a look at angle DBA, it's really an angle made up of two smaller angles, 2 and 3. And again, guys, this is brand new, so I don't expect people to be like, oh, like I totally get that, right? No, this is new. Okay, so that's what angle DBA is. Well, I'm going to do the same thing for angle EBC. So I'm going to go over here and go like this. So angle EBC, that's really made up of two smaller angles. So I can say it's angle 2 plus angle 1. How did I get that? Angle addition, right? It's okay if I do the same thing more than once. Okay. Now, what I've done, you're like, why did you do that? Well, one, notice how I got these angles in my proof, right? Now I have angle DBA and I have angle EBC in my proof, so that's good. I have them there. But also notice how we got some algebra. What are we really good at, guys? We're really good at algebra. So now that I have it in terms of algebra, now we can do some algebra. And I bet some of you, because whenever I teach this, I always have people who are like, ooh, I see something. Okay, so let's hold on for a second. So I want these two to be equal. Let's see what they have. They both have a 2. That's really good, right? Do you guys see how this one has a 2 in it and this one has an angle 2? Well, we want them to be the same. The only thing that's different is these two, right? Angle 1 and angle 3. So somehow we have to show that these are the same, right? Because angle 2 is the same, but if we can show that if these are the same, I'm playing coy, so I appreciate you being nice, right? So if these are the same, wouldn't these be equal? Oh, wait, look at the given. Angle 1 and angle 3 are the same. So check this out. For my fourth step, I can say, let's say I take angle DBA is really angle 2 plus angle 1. So what did I do here? I took angle DBA and I replaced 3 with 1. So this is called substitution. Right? Because if 3 equals 1, do you guys see that? How is 3 equals 1? Then I can replace that 3 with a 1. So now I have this. Now I have this. EBC equals angle 2 plus angle 1, and DBA equals angle 2 plus angle 1. Well, if they equal the same thing, aren't they the same? Yes. So we would end this by saying the measure of angle DBA, and I'm going to write it exactly how they wanted it, is equal to the measure of angle EBC. And for my reason, this is where we use transitive property. And why transitive and not substitution? We use transitive property here because it's chaining a whole bunch of things together. Substitution is only used when you replace one thing. Now, I'm gonna let you guys know this. On tests, on the midterm and the final, if you guys write transitive property, I will give you credit for transitive or substitution, okay? Because the difference is really slight. But the rule of thumb is substitution, you only replace one thing. Transitive, you replace a whole bunch of things. Okay, so there you go. There's the proof. Okay, now this looks really different, and for some people that can be overwhelming because it's so different. But remember, this is not on your homework tonight. This is what we're going to be talking about. We're going to intro this next class. Okay, so before you guys leave, there's a couple of announcements that I want to make sure you guys understand. So this is okay. So this is second period. So on 1/28, okay, so on 1/28, so when is that? That's next Monday, that's a week from today, next Thursday. We are going to be reviewing for your midterm. That means in class, we will do a review, and then the midterm will be posted, and you will have from that Thursday till Monday to work on your midterm. So your midterm is a week from today, okay? I just wanted to let people know. So your midterm, remember, is worth 10% of your grade. It will be, so again, it's going to be a week from today. So make sure you guys are getting your homework done. Make sure if you guys need help on your homework that you let me know, because you want to get all that done before next week on our midterm. Okay, so that way you can use your homework and use your notes to do the midterm. Okay? Does anybody have any questions before I end class?